So since we started doing these projects in 2011, we've done tens of them. Many of them have been for New York City, municipal government. And so is this next project, which examines climate change and stormwater management. Please welcome our next presenter to the podium. Sam.
Thank you. Good evening. My name is Sam Stockdale, and I'll be representing the Stormwater Management Capstone Group. So tonight, we'll introduce our client and context. We'll go briefly through our project objectives. We're going to dive right into our findings and research best practices. Then we'll discuss a subset of our recommendations, and we'll end with our conclusion and key takeaways. Our client for this semester is the New York City Department of Environmental Protection. For those of you not familiar, DEP serves three critical functions for New York City residents. One, they manage the city's drinking water or potable water. Two, they manage the city's wastewater. And three, they manage the city's stormwater, which will be the subject of our presentation this evening. So our project was to assist DEP in how best to incorporate climate change projections in their stormwater management plans. We had four critical focus areas. One was to conduct an audit of their current state to understand what they did well, maybe what they could do better. 2 and 3 was to research national and international best practices and specifically look for innovations, which we did through targeted interviews with stormwater management experts. And finally, we need to bring forward a recommendation for what we might think is relevant or applicable to New York City and why. So why is this important? So 2 of those services that DEP provides that I mentioned earlier are linked. And sewer water and wastewater often travel in the same combined sewer system. In New York City, that sewer system is combined for 60% of the total sewer infrastructure. So when you have nuisance events called cloudbursts, which are extreme intensity precipitation events, or long precipitation events, these systems get overwhelmed. And the result is raw sewage outfall to New York City waterways, which is represented by the picture on your left. Now, there's one thing that we need to understand about DEP, which is that they serve a function as a compliance and regulatory body. So what that means is that they are responsible for ensuring that EPA-mandated standards to water quality from the Clean Water Act are met. And so when we consider that 60% combined number, that has a material impact because there's a greater chance that they're going to have some kind of regulatory or compliance item that's triggered as a result of that raw sewage outfall. So when we did a deep dive on New York City's current state with respect to stormwater management plans, they did a lot of things really well. And they have an incredible green infrastructure program. They have a lot of success in targeted programs, specifically in Staten Island and the Bronx. But a wholly integrated stormwater management plan that incorporates climate change projections hasn't necessarily taken shape. And when we try to understand what climate change projections specifically need be incorporated, this table at the bottom is representative of a 2015 study that the New York City Panel on Climate Change conducted. And what's interesting about this is that 4 years later, that same panel reconvened and did a post-mortem study, or a 4-year look back. What they found is that the actuals fell pretty firmly within that middle category. When we zero out and look at this issue from a macro perspective, we find that between 1958 and 2011, New York City had a 70% increase in storm severity. So the data and the science tells us that not only is this not going away, but it's going to get worse. So we're going to jump right into our research findings and best practices. And as we started reaching a critical mass of data and research, which included interviews with 15 stormwater experts, chief sustainability officers all over the world, and managers with different environmental departments of cities, we began to see that the tools that they're using to manage climate change projections and stormwater management in general fit into these 5 categories on the left. And one thing we'd like to point out is that many of the folks that we spoke to out in the field outright said, we're not doing this. We're not there yet. We're still in the planning stages, and we're trying to understand what parts of climate change need to be incorporated and what the requisite impact then is on our stormwater management plans. So that was a significant discovery in and of itself. But for the sake of time tonight, we want to focus your attention to our top 2 best practice findings. And one, we want to focus on funding mechanisms specifically because any type of outlook projection introduces budget risk. And so we have to discover tools that create revenue streams to fund new initiatives. And second, we want to talk about modeling and the use of technology because we want to stay true to our subject matter tonight. And this really is the main tool that those cities who are incorporating climate change projections are using to get there. So we'll begin with funding mechanisms. And the way that this is laid out is we have our best practice subcategories on the left, and we have our case study cities on the right. And there are some familiar players here, like the issuance of public debt, which usually comes in the form of a general obligation bond, which is a pretty typical tool that cities use to fund public infrastructure. And Houston, for example, just approved a $2.5 billion general obligation bond to fund drainage projects and flood mitigation projects in the wake of Hurricane Harvey. And Cincinnati and Seattle are looking at implementing stormwater fees, which is in addition to and separate from your sewer fee that you get from the utility. But I think what we want to focus on tonight is Washington, D.C., which really gets our innovation spotlight. And what they did is they pioneered the first ever environmental impact bond in partnership with the Nature Conservancy in 2016. An environmental impact bond is similar to a green bond in that certain environmental standards have to be met in order to be approved for funding. But there's an additional concept here that takes into account the shared risk approach, where positive components of the project are returned back to investors in the form of increased returns or a bonus incentive. And on the other side of that coin, the negative aspects of the project, those investors accept a reduced return. And so this is relevant for DC because it allowed them some flexibility in discovery for what works best in achieving a long-dated goal, and and it also enabled them to guide future investments and proceeds from that bond accordingly. So same drill, subcategories on the left, case study cities on the right. When we look at modeling and the use of technology, what we found that was really interesting was that no cities use modeling or technology the same way, nor do they model the same thing the same way for the same outcome. And for example, Washington, D.C. Is another great best practice where they commissioned a third party at the cost of $5 million to build in this 3D model that looks at climate impact scenarios. And they're actually able to run what-if scenarios for different kinds of climate impacts on different portions of the city. Portland built a climate intensity demand curve, almost like an economic model, to look at different kinds of climate severity events, and they overlaid that on a pollutant load model to see what those regulatory impacts would be triggered by varying degrees of climate events. Rotterdam took a more quantitative framework to this, and they wanted to look at risk of damage in the face of climate-related events. And so they actually assigned a letter grade to every individual building in the city, from A being the best to E being the worst, and they made that information publicly available to developers, to private citizens to do with it as they may. Cincinnati gets our spotlight for the modeling and use of technology best practice because they went straight to operations, and they skipped climate projections altogether, and they said, we acknowledge that stormwater management is going to get more difficult. And we acknowledge that we have an aging sewer system that would be too costly to upgrade. So they built an electronic riser diagram and cataloged their entire sewer system, and they overlaid a control system on top of it that allowed them to control flow when the climate event happened. And so what they found was that this solution was 95% more effective than traditional investments in gray infrastructure like pipes and tanks when the bad stuff happened, when the climate event happened, because they were able to direct flow within their existing system. So this brings us to our recommendations specific to those best practices that we've discussed tonight, as we think that New York City should incorporate modeling across 3 verticals, which is a combination of the best things that we've found. And one is we think that they should build that 3D impact what-if scenario model to understand how different portions of the city or different boroughs are affected by different kinds of events. 2, we think they should have an electronic riser diagram of their infrastructure. They should go from analog to digital in cataloging their sewer system. And 3, we believe that they should use some kind of risk or quantitative framework to understand with these 3 things together what kind of damage risk or flood risk as it relates to climate change that they could be exposed to. 2 is we find this environmental impact bond concept very compelling, and we find it compelling for 2 reasons. 1 is we think that it would be very interesting if the New York City Office of Management and Budget issued this bond as a general obligation bond rather than normal course of business where the New York City Water Authority issues bonds for the sewer system. And we're making that recommendation because if you raise it up above DEP specifically, you allow other agencies who touch stormwater to participate. So for example, agencies like sanitation that can have a market effect on pollution, or transportation, which as you can imagine has an effect because of all the impervious surfaces. So with their different participation, you have a larger range of impact or mitigation prospects to help you manage this. The second reason why we like the environmental impact bond is just because of the timing and the fact that this ESG and impact investing movement is really gaining momentum where investors are increasingly looking for environmental and social returns in addition to traditional financial returns. So in conclusion, we want to leave you with 6 main takeaways. And the first is that while the science of climate change and stormwater management separately have had relatively long histories, the practice of combining them we find is very nascent. And everyone that we spoke to said that, yes, we're looking at this and we're thinking about it, but we're in the planning stages, or we've just recently implemented a project. And the result of that was it ended up with a difficult prospect in us trying to turn that around and deliver a solution set to DEP that says, these are the metrics, this is what works, and this is why. So we focus more on maybe the qualitative rather than the quantitative. On the positive side of things, consensus was a real eye-opener for us. And everyone we spoke to said, yes, this is in our roadmap, yes, this is important, and yes, we're implementing. And because of that, it guided our approach to bring forward a portfolio of options within different verticals that have varying levels of impact, which we believe make up the whole of an integrated plan. And lastly, this nascent practice is also a good thing. And it's dynamic because innovation is the breeding ground for new methods of risk management, new ways to fund infrastructure. And we think, hopefully with our recommendations and a little bit of time, DEP in its own right will be an exemplary case study for future programs like Columbia. Thank you very much. Questions?
Questions for Sam, please.
Hi, thank you so much for that. That was really interesting. I had a question about the Rotterdam example. That sounded really interesting, how they were mobilizing the market to kind of solve the problem in a way. I don't know how that has run. Has it been successful? How long has it been running? And how did they incorporate things like perhaps lower income areas who probably have less access to some of this infrastructure? And is that built into their considerations, and how do they do that?
Thanks, that's a great question. So I think that the major shortfall of our entire project really falls in that metric category. And where the government agency that manages stormwater specific to Rotterdam, they are responsible for commissioning the study, the actual precipitation study, that then led to their damage and risk assessment. And so when they made it publicly available, they actually weren't tracking what investments were being made by private landowners to try and mitigate those facts. That being said, though, Rotterdam and Amsterdam, and some of the other international cities that we looked at really are at the most progressive end of stormwater management. They really are the ones that are doing all the things that we would like to mimic if we had all the funding in the world. They've built incredible bioswales and drainage corridors, and they've implemented certain kinds of green infrastructure that you don't necessarily see here in the United States. So I think that that's something that would be a terrific follow-up.